Okay, this is number 21 on section 7.2, and we want to find the area between these two curves, y equals the absolute value of x squared minus 4 and y equals x squared over 2 plus 4. And the challenge is the absolute value issue. You should be able to sketch these without using a calculator. We can check with our calculator in just a second. Now remember, the definition for the absolute value of x is x if x is greater than 0, greater than or equal to 0, and negative x if x is less than 0. It could be also less than or equal to 0 because it's equal to 0 when x is equal to 0. So first of all, I start out by sketching this curve, just x squared minus 4, which is just a parabola, and it would go like this. You see where I kind of erased it. But it's x squared minus 4. But if I take the absolute value, whenever that's negative, that means it's below the x-axis. I have to take its negative, so we just flip it. So from here to here it's positive, but then here it's negative, so I flip it, and I go back to positive. So this green curve, okay, that ends up being the y equals the absolute value of x squared minus 4. Okay, now the orange curve is just the second equation, y equals x squared over 2 plus 4. That's just a little flatter parabola, and it's shifted up 4, so this is equation number 2. So now we can really define this by using this absolute value as y equals x squared minus 4 when it's greater than 0. And if we look at our range here, that's going to be from 2 to 4, or from negative 2 to negative 4. And it's going to be negative that. Remember, if x is less than 0, that's over here when it's below. So it's negative that. That's what I've graphed this. And that's going to be negative x squared minus 4. That's when that is less than 0. So that ends up just being 4 minus x squared. So it does look like a parabola. See, it looks like a parabola that's shifted 4 up, and it's the negative x squared parabola. So that makes sense. Okay, so this is how we could graph that absolute value. Okay, now we want to find out where they intersect, so I just check both, and I have to check both branches. So if I can check these to the positive when x is greater than 0, I just set this equation equal to the second equation. I'll multiply both sides by 2. And then I can combine terms, so I can subtract x squared from both sides, add 8 to both sides, and then take the square root, so plus or minus 4. So that's when these intersect, when x is plus or minus 4. Just put a negative 4 over there. And then when I want to find out when these two curves intersect, when it's the negation of x squared minus 4. Then there's my first equation, but remember that's the other form. That's this part. Okay, 4 minus x squared equals x squared, and I kind of highlighted these in orange, because that's the orange curve. And then multiply by 2, so I get 8 minus 2x squared plus 8. And if I subtract 8 from both sides and add the 2x squared to both sides, I end up with this 3x squared equals 0, so x squared equals 0, and that's where they intersect. That makes sense. Now notice that these are both even functions, so I can use the symmetry. In other words, I don't have to integrate from negative 4 to negative 2, negative 2 to 0, etc. Have 4 integrals. I can just take these two integrals from 0 to 2 and 2 to 4 and double that, and I'll get the area for this whole region. Okay, so that's the approach we'll take. Okay, so this was finding my intersection points when x is 0 and when x is 4. But I'm going to have to integrate this region from 0 to 2 because that's when I have this form of x squared minus 4, and then I'll have to integrate from 0 to 4, and I'll have the other form. Okay, so I have different forms of the absolute value of x squared minus 4, so these two forms. So I set up the integral. There's a bit of work to do as far as calculation, so we'll go over that. So this is the way you set up the integral. Oh, by the way, I forgot, you could have done that on your calculator. Let me just show you that on the calculator real quick. And you could have put those in your calculator like this. The absolute value of x squared minus 4, and then x squared over 2 plus 4. You could have put those in, and when you check the graph, that's kind of what we got. So you can see that's what we got. But it's kind of nicer to do it without the calculator. Show that you can do it, but you can always check it with a calculator. Okay, so let's take a look at this integral. So this is the portion, this is the top curve minus the bottom curve, but we have two integrals. So I'll go back and I'll refer to the sketch first before we start working on this. So this is 2 times, so we're going to double it because we're going to use the symmetry. And this is from 0 to 2. Okay. So I don't have to do both. So I'm going to go 2 times from 0 to 2. And the top curve, again, is my orange curve. That doesn't change. And the bottom curve is the negated form. So that was this over here. 4 minus x squared, because this was in the negative portion, so I had to reverse it. So there's my negated form. And then I'm going to go from 2 to 4 of the top curve, same curve, minus the bottom curve, and this I didn't need to negate because it was positive. So that's how we got that integral from the sketch. And the rest is just mechanical work. And again, you could put these in your calculator and check them. But what we're going to do is simplify this before we take the antiderivative. So 2 times the integral. And then I could say x squared over 2. Now 4 minus 4 just cancels, and that's negative times a negative is plus x squared dx, so that's nice. That removes a little bit of work there for a few terms, and that's going to be from 0 to 2, pardon me, and this is going to go the integral from 2 to 4, and then I'll simplify over here, and we end up with a number here that's not going to simplify, so we'll have x squared over 2. And then I'll have my minus x squared. I'll put that next to it so I can simplify that. And then 4 and a negative times a negative 4 is positive 4. So 4 plus 4 is 8. It's not too bad. Now I can simplify these some more. And this would be 2x squared over 2 plus x squared over 2, which gives me 3x squared over 2. So now I got one term. That's nice. Okay, and then this is going to be negative 2x squared over 2, so it's going to end up with a negative x squared over 2 plus 8. So now I've got those integrals simplified, so I'm now ready to take the antiderivatives. So this is going to be 2 times, and if I add 1, that's going to be x cubed over 3, and then those 3's a cancel, so it just ends up being x cubed over 2, which is nice. And that's from 0 to 2. So that the 0 will drop out, so I'll just have to evaluate it to 2. Plus 2 times, now this is a little bit harder because I'm going to go from 2 to 4, and that's not going to cancel, so I'm going to have negative x cubed over 3 times 2 is 6, plus 8x. And again, I'm going to have to do this from 2 to 4, so this would be kind of a hassle. Okay? So this is going to end up equaling. So if I put these in, I'm going to have 2 times. And then x cubed, if I substitute 2 in for x, I get 2 cubed, which is 8 over 2. And then if I put 0 in here, that's just going to be 0 over 2, which is 0. 2 times 0 is 0, so that drops out. And then this other part over here, plus 2 times, and this is where it's going to be a little bit of work. 4 cubed is 64, so that'd be negative 64 over 6. Plus, and if I put 8 times 4 is 32. Then minus, so that's our fundamental theorem of calculus, f of b minus f of 8. So I'll put 2 in here, so I'll put a parentheses, and negative, and 2 cubed is 8 over 6. And plus 8 times 2 is 16. So some good old arithmetic here, practice. Okay, 2's cancel, so I just have 8, and then this is going to take a little more work here to simplify this out. So I can reduce this to be 32 over 3, so that'd be negative 32 over 3, and then I can make this plus 96 over 3, so I get a common denominator. All right. And minus, and that's going to be negative 4 over 3, and this will be plus 48 over 3. You guys all just love to do these fractions. Okay, and that's going to equal 8. Okay, plus 2 times, and I can combine that, that's going to be 64 over 3. 64 over 3. All right, 96 minus 32 is 64 over 3. Minus, and this is going to end up being 48 minus 4 is 44 over 3. And ends up being 8 plus 2 times, and this is going to be 64 minus 44 is 20 over 3. Okay, and this ends up equaling 8 plus, and then 2 times 20 is 40, 40 over 3, which equals 8 plus, and then 3 goes into 40, 13 and a third. 3 times 13 is 39, so it's plus 13 and a third. And finally, if we add these up, we end up with 21 and 1/3. So there's your answer, 21 and 1/3. So that was a bit of work. Sorry about that, but if you do it analytically, it comes out. But like I said, it's a lot of fractions. So go through this, think about this, think about sketching it on your own, because that's what's going to help you to understand all these different aspects of the absolute value. So you can get a lot out of this problem if you really study it.